rid of that slope, we factor in the slope of the relationship between the covariate and the dependent variable. And that should produce lower within group variables.
Is the covariate kind of like a mediator?
No, it's more like a moderator if anything, but it isn't really either of those. Just another factor. I'll give you some examples. And we have a couple of new assumptions here that we'll go through that are a little complex. So we have our usual big three: normality, homogeneity, variance, and dependence of observation. Those still hold. Now we have a couple new ones. Linearity refers to the relationship between CV and the DV. That's a scatter plot between them. So the covariate is a variable that correlates with the dependent variable. We want to see what the relationship between those is. And we're assuming that it's linear, not curvilinear. And COVA doesn't work if it's curvilinear. The covariate is supposed to have high reliability of measurement. If it doesn't, it kind of is an assumption violation. And the new one that's a little more complicated is called Homogeneity of regression slope. What that one is that the relationship between the CV and the DV remains the same for each level of the IV. The relationship between the CV and the DV remains the same between each level of the IV. So if you have three groups, you look at each group separately, you look at the slope of the covariate to the dependent variable, you're assuming that the slope is about the same. In other words, if something relates to the DV, it relates about the same each way. So let's look at some examples. I've said those already, I think. Just saying what I just said. Linear regression is used when the true regression is curvilinear. So those are the scatter plots: covariate versus the DV, covariate versus the DV for group A, for group B. But now what happens if group A and group B don't have that? That's another version of heteroscedasticity. See how the slopes are different in the two? So we're going to test to see that those slopes are the same. We're going to actually do it with a real example in a second.
You're saying one graph with the other.
Yeah, you're going to compare we're going to get the computer to compare one slope to the other slope. So that's a slope. We can test this assumption, but then we'll show you how to test that assumption. Some tricks to it. All right, so a couple examples before we get to our main example. Researchers looking for performance on crossword clues. Subjects have been grouped into three vocabulary levels: high, medium, and low. ANOVA and two keys on this data find that the high group and the low groups are different. So you do a straight ANOVA on that, okay? However, the amount of experience in solving crosswords might make a difference, right? So there might be a relationship between experience with crossword puzzles and your ability to do them. Plotting the scores against the age, we obtain a graph. So we see, okay, older you are, the better your performance. And it's the same for high, medium, and low, but they all have the same slope, but they do differ from one another independent of age. So if age is mixed into those, it just comes in as error, right? So if you don't control for age is just the source of error there. So now we're going to be able to kind of tease that out. From that, we're going to get two elements: adjusted or estimated mean, significance, testing significance of the covariate, and testing of assumptions. And here's an article that warns you about all the terrible misuses of COVA. In case you're ever actually doing one, you'll have this graphic go back and look up. We're not going to worry about it right now. There's a million. This guy makes you feel like nobody should ever do it in COVA. but there are some good uses. So the example I chose for today is from this other book by Andy Fields. It's a comical one. Thought we could use a little levity today. And the problem is you're testing the DV is the libido of the subject. The independent variable is 3 doses of Viagra. Low, medium, and high. So in the initial analysis, we just do the straight ANOVA, the way we usually do, and find that there's a difference in libido with the 3 levels of Viagra. Pretty obvious. But then it occurs to the researcher that maybe the libido of the partner might have an influence on the libido of the subject. Right? So I guess it's the Viagra, I guess the subjects are all males, and the partners, I think, we'll assume the partners are female. They don't have to be those. Could be either one. So if we thought that was the case, we would think that the partner libido might have an influence on the data, both within group and even adjusted the scores. So we wanted to control for the libido of the partner and still do the comparison of the 3 doses of the drug. We could do that with an ANCOVA.
You say that one more time?
Yeah, so we want to know whether there's a difference in the dosage levels, but we want to control for the libido of the partner, because that is not going to be what we really care about. We want to know if the drug works independent of other factors, right? So we'd like to hold constant, and you can imagine that the libido, the willingness of the partner to engage in sexual stuff has something to do with the libido of the person themselves. That's its premise on this one. He comes up with these wacko examples. All right, so doing them is pretty easy. We just use general linear model, univariate. Libido is the DV, the dose is the fixed factor IV, and the partner's libido is the covariate. We just have one more thing to put in. We have our usual suspects for options. First 3 on the left, top one on the right. Get the means. Make sure you always get the means in this one because those are a special kind of mean. You can do post hoc tests just as well as always. Here, we're not bothered with it now. You can do a plot. It's a simple plot. So this is nothing very new that we haven't done. Just putting one more thing in the box. Everybody okay with that so far?
What did you put under covariate there?
The under covariate was the partner's libido.
Okay.
And I gave you the output then. So here's what the output looks like. There's a few little things to note here. The first thing are the unadjusted means. So those are the means of the placebo, low dose, and high dose. And their standard deviations. You can see here it doesn't have even sample size here either, they're slightly different. The Levine's test is the same as we're used to. It's the test of homogeneity of variance. If it's significant, that means we have violated homogeneity. But the output here is a little different. As usual, we ignore corrected model and intercept. But the dose is our main IV. Right, see that? And it's significant with a decent effect size, 0.016. So that means there was a difference between the dosages, even controlling for partner libido. Now, did partner libido have an effect? Well, that one you test by looking at whether that's significant by itself, and it is. So that line doesn't tell you anything about dosage, it just tells you whether the covariate is significant. That's important for that output. All it tells you is the covariate significant.
Which one?
So this .02 tells us that the covariant was significant. There was a significant correlation between the covariant and the dependent variable. Significant for a covariant means the correlation is not zero. We're 98% sure that the correlation is not zero.
Okay, covariant
And the-
covariant.
And the DV, CVDV. That's okay, so the ANCOVA worked. I should do the ANOVA without it, and you can see the difference. I'll do that in a second. So remember what these significance levels are like. It also gives you something new, which is what's called estimated marginal means. Those are the adjusted means. So remember, if we look up above, look at your data above for the unadjusted means, you'll see these slightly differ. Right, so 3.22, 4.89, and 4.85 versus 3.31, 3.07, and 5.920. So that one got a lot bigger. So these are the means of the dosage levels independent of the partner libido, with that parceled out.
Can you repeat that?
And those are the means of the three dosage levels independent of the partner libido, independent of the CV. And they're adjusted so that we now have a mean that we think means something without, once we've controlled for the CV. So we now control for the CV, just like we do in regression.
So this is all about reducing error.
It's mainly about reducing error, but it also does make some adjustments to the means, which means we have a more accurate way of assessing the IV. And if you look at the data, you can see that the big difference there was between the high dose. The low dose didn't do any better than what the placebo does look like. It's actually a little worse maybe. And the high dose was a lot higher. And that graph is of the adjusted means. Sense? So you can think of other more salient examples for us. If you were comparing 3 treatments for PTSD, let's say we're doing exposure with some somatic component, and support groups for 3 treatments for PTSD. Let's just say for now we're going to look at the outcome scores without the pretest scores. It gets complicated to do pre-post with covariance, so we'll just leave that aside. So let's say we have improvement scores for 3 groups. These are exposure therapy. This is exposure plus some somatic therapy like yoga or biofeedback. And this is a support group therapy. And these are percent improved scores. Okay, can anybody think of any possible covariates that we might want to look at for
So what are the categories? Support?
that? Exposure plus somatic, and just support therapy. So we're testing 3 different kinds of therapy for return vets with PTSD, let's say.
Intrusive thoughts could be something.
Hi, Reggie.
Like intrusive thoughts.
Thoughts?
Intrusive thoughts.
Intrusive thoughts. Okay.
Quantity of traumatic incidents?
Okay. Yeah. So what? So
Quantity of traumatic incidents?
okay. How about there's another scale called the combat experiences scale, in which the vets are asked how many. Check things that happen to you in your deployment. I witnessed a buddy getting killed. I was affected by an IED. Somebody that I trusted, an Iraqi that I trusted, turned out to be a member of Al-Qaeda. A whole bunch of those. So you get a score out of that. Those are good scales because the vets usually fill them out fairly honestly. They don't fill out symptoms honestly, but they do fill out events honestly. So now, why would that be relevant as a covariate?
Probably correlate the number of the traumatic events they have, probably increase the severity of them.
Yeah, so the more, so that would be true, but why would we care about that for us? So let's say we're trying to see if there's a difference between these three therapies.
Maybe someone with more severe symptoms would be better suited to.
Exactly. What if the therapies interact with the combat experiences so that there's a lot of error within these groups that have to do with the combat experiences, right? So we get a lot of within-group error in terms of how well they respond to the therapies because of those combat experiences. It would be nice if we could control for that. So essentially, we statistically control for combat experiences and then get like a purified score to compare. That would give us a little better idea of possibly how it worked. Now, if combat experiences didn't correlate with how much they improved, then it would be a waste. But it's pretty obvious that they probably would, right? We know already. Or the number of, remember the other study, the number of intrusive thoughts and dissociative experience, dissociation. Another one might be dissociation, another covariate might be dissociation, right? How much dissociation did they experience after the trauma? Remember we did that one, that was real data, but we have a dissociation experiences scale. Ask questions like, after your event, did you find yourself places and you don't remember how you got there? Did you find that you're getting spacey a lot after the event? Things like that are kind of dissociative symptoms. So those symptoms might have been listed. No, you'd think that probably, in fact, we know from previous literature that high dissociation really is a very powerful impediment to good exposure therapy, right? Because what happens to those folks is the minute you expose them to their trauma scripts, they dissociate, they don't make any progress.
Would another potential one be like when we were discussing the Holocaust survivors, something like hardiness rating?
Yeah, it could be, although usually that would not be a nuisance variable as much as, what would be the comparison now? You compare it?
I guess I would maybe expect a little bit of difference depending on their kind of hardiness and whether...
What's the IV though? So you'd have to kind of decide what the IV is. But I mean, if the IV was age of death. Okay, so we're going to compare, let's say we're going to compare World War II Holocaust survivors to the Balkan War survivors of slaughters. I don't know, it's a horrible study. Versus something else, and we wanted to see if the three of them had impaired. Usually, those kinds of experiences shorten people's lives pretty regularly. People who have been through the slaughters in the Balkans have shorter lives. The Holocaust have shorter lives. Lots of trauma.
I was just thinking, I guess, that the IV would be the... I'm sorry.
But usually if we were doing hardiness, we'd be more interested in that as kind of another IV probably. We want to know if hardiness affects those. We wouldn't want to get rid of it probably. So that one might not work so well.
So covariant is a nuisance variable?
Well, or a variable that you want to control. You want to control to get rid of it, usually to reduce within group variance, but also to make some adjustments in the means. So in this case, I think that would be a good example of that because we don't really care that there's, we're hoping that the combat exposure scale is equivalent among those three groups. It very well could be if we do random assignment to these three. So if they come in to Fort Campbell or to Pendleton and we say, okay, we're going to be a study, you're going to be randomly assigned to one of three groups for treatment. We think they all are good, we just want to see if there's a difference. And now we're going to ask you to fill out some questionnaires. We already know from the study we just completed that the trauma symptoms are useless. We have a big study of 1,000 returning troops, pre-deployment, post-deployment. Their CABS test, their test on trauma symptoms actually got better pre-deployment to post-deployment, which isn't likely. So what happens is they just won't tell you trauma symptoms. They won't report trauma symptoms. Marines especially will not report trauma symptoms generally, unless they're going for disability, in which case they'll exaggerate them like crazy, right?
And they'll never go away.
And the way the reason military intelligence is an oxymoron, because the way the military decides on what kind of disability you're going to get is they put you in a inpatient program, they do therapy. At the end of that time, your disability is determined by how you're doing at the end of that 3 weeks. So if you want to go in and do a study in those groups, all the incentives are for getting worse, which is what they report. So not a good idea, but anyway. So we know that the CAPS won't give us good numbers, but the combat experiences scale seems to be a pretty valid scale for this group. They don't tend to exaggerate. I mean, if a buddy got killed, the buddy got killed. People don't say that if it didn't. So they're actual experiences that they can quote. And most vets are pretty willing to tell you on a scale what happened to them. So that would be a good covariate here. And the hope would be that it would reduce within group variance. All right? So that we would be able to get a better estimate of how these 3 therapies worked without something that messes them up by giving more within group variance. So.
In general, even though it's a covariate, it wouldn't also like really help you figure out what exactly is going on.
Yeah, so the correlations themselves are interesting, right? If CES is, that's independent information that's interesting. In fact, if the combat experience is not related to your outcome in therapy, that's interesting to know too.
Yeah.
I mean, if you had a therapy that was so powerful that it didn't matter what kind of experiences the person had, but the therapy works the same anyway, that would be very interesting to know. But remember, if it's not correlated, all you do is lose a degree of freedom. You lose power. So you don't want a covariate that's not correlated.
So like for this example, since there'd be like different number of traumatic experiences, could you go ahead and group those like 1 to 3 group versus? You
can always make another independent variable. So that's one of the options is.
Yeah.
And expand this to low CES, to make it 2, to high CES. If we're really interested in seeing how the therapy works for those 2. But that might cut your sample size in half.
Well, yeah, in theory.
Yeah, so but it might be useful, so that might be a useful one. So that's always a possibility that instead of covariates, you just have another independent variable. That's always an option you might have. But sometimes the other ones are just not interesting, and it's like biasing in response or something like that. You don't really care about making that an independent variable, whatever that might be. Okay, get the idea of it? All right, now it gets a little more complicated to assess the interaction, the assumptions. So I've got a little cheat sheet for you to do it on SPSS. Part of this one, so just a part that says testing assumptions. Let's go back through the assumptions again. Let's use this example since it's a little bit less silly than the other one. I'm going to show you the other one. All right, so in this example, the assumptions are the usual suspects: normality, homogeneity, and it depends on observation, and we'll do those again. But the additional ones are linearity of the relationship between the CV and the DV. Right? right? So there you're having the DV, remember, which is percentage improvement in trauma symptoms, and the CV, in this case, is the CES, combat experiences scale. So we want to look at the scatter plot between those two. And the assumption is that the relationship is linear, not curve linear. Because you're going to miss the relationship if it's curve linear. So that's pretty easy to assess. It's not often that we're going to get a curve linear relationship. You just look at scatter plot, you can assess that. Okay. Next, the assumption of reliability would just have to do with how reliable that CES scale is. Let's assume we've met that assumption here. The final assumption is a little more complicated. This is the assumption of homogeneity of regression. This assumption is that if we looked at 3 scatter plots, one for each level of the therapy, and did a CV, DV scatter plot, that the slopes would be approximately equal. Think about it, it makes some sense. If there was a different relationship between combat experiences and trauma symptoms for the support group than there was for these groups, we kind of mess up what we're trying to do, right? We're sort of assuming that whatever that CV is, it has kind of a common relationship to all for each level of the IB. And the consequences of violating that assumption are quite complex. Sometimes it could be type 1 error, sometimes it could be type 2 error, depending on which way it goes. So it is an assumption that we do need to pay attention to. If we violate it very severely, it may be that ENCOVA is not the appropriate technique to use. But get it?
So if it would have different effects on exposure or exposure length, you would see a different slope for each one of those?
Or maybe just one of them.
Maybe just one, okay.
That would be a violation, right?
Saying that the combat experience scale
Doesn't correlate with
Or
the
not.
outcome for the supporters. And if you don't have random assignment, you can see how easily that could happen, right? If you had, let's say you're comparing, instead of 3 treatments, you're comparing, let's say bulimics, anorexics, obese, and the CV is family health or something. I don't know, attachments. Let's think about what could be a covariate for those 3. Well, weight. Weight could be, right? So BMI. Well, you know it's going to differ between those 3 groups. And so you can see kind of a mess that if BMI correlates, certainly will correlate with the, we're trying to say that DB was attachment history thing. So let's say weight correlates with attachment history only for the obese and not for the bulimics or something. And that would really mess up our whole study.
So would that be where we basically added one, we've added degree of freedom, but we've added something that's not correlated?
Well, no, it might be correlated for some parts of
For
it,
some parts.
but if it's correlated for some and not others, where our conclusions could be skewed one way or the other.
But say one of the treatment conditions worked really well for a higher quantity of traumatic events. Wouldn't that create a different slope? Like say support is just
might.
better for the...
Yeah, that's what Jen was saying a minute ago. So then we would want to know, we probably want to redesign the study to have separate groups of CES then. Because that's
make it an IV instead of...
Yeah, exactly.
I see, okay.
And then we could actually see how it works for different things.
Okay. That makes sense. Okay.
When we're looking at the different slopes on an output, should we look at the plots?
Well, I'll show you. Yeah, I'll show you. So we're going to actually do that's the sheet I just gave you. We're actually going to do a little trick to get that. And then we look at the plots to see what that tells us. So this is something we haven't done before, so let me show you that. So what you do, you use the same exact program here. General linear model, you can follow along that sheet I just gave you. But we're going to do something a little different than we haven't done. We're going to click model. And we're going to click Custom. And we're going to put each of the, what it gives you is the factors and covariates, CVs and IVs. We're going to put both of them over. And then we're going to highlight both of them together with the Shift key and put those over as interaction. And then we're going to go to continue. So what we're going to do is we're going to create an interaction between the IV and the CV. Think about it. If the IV CV has an interaction, then those slopes won't be parallel anymore, right? So it's just a way of testing parallel slopes. It doesn't tell us anything more than that, but it can tell us if those slopes are parallel. And so that we'll see if they're significantly different than parallel, then we're going to have a violation if they're not significant. Now the thing to remember is the output that you get now is only useful for testing this assumption. Nothing else on the sheet is of any value to you. You can't test the main effects anymore because you're putting in this bunch of other stuff. So once I click continue, I think I gave it, did I give you the output from that? From that one, I think I did, yeah. Now you get some new output. Ignore everything else in that output except this line right here. Unrelated, ghost by partner. And here we got, it is significant, 0.046. See that? It's on your sheet there.
You don't have
Don't have that one? Did I not give you the three graphs in there too? No, not, it won't be on that sheet. It's on the original, sorry. On the original libido sheet. Remember the data we're using is the libido one. So go back to that first one again.
So we just have a partner in June.
You don't see the dose by partner in there the second time through? Look again. Flip another
We
page.
don't have a second time through.
Oh, trust.
We have a plot.
And I did the plots, but I forgot to give you the sheet. All right, so but this is the sheet that I should have given you. And the only thing we care about in this plot, the second sheet I gave you is just how to do it in SPSS, is the significance there. So we did get a significant interaction between dose and partner. Now if you do the plots that you've got, to get the plots, what you have to do is you go to Data, Split File, and do it by the IV, which is dosage. Remember how we did that before in the first semester? And now I'm going to just do a scatter plot, graphs, legacy graphs, scatter plot, fine. And I'm going to put in the DV, CV into each scatter plot. And that one I did give you apparently, huh? And remember what you do to get the lines is you double click on the graph. And then when it comes up, right click it and do add fit line to total. Click, right click, add fit line to total. Oops, I must have missed one. There we go. Right click. All right, so you can see where the violation is coming from in those three graphs, right? The first two have almost identical slopes. But for the high dose Viagra, it didn't really matter what the partner's libido was. There was no correlation between the partner's libido and their libido. Right? So ANCOVA was a little bit of a problem here because of that relationship being kind of messed up. Huh?
So first of all, if we found the interaction to not be significant, we stop there.
We're good.
Wait, that would be good?
That's good.
Okay. And then since it was significant here, we investigated. But how close do these slopes have to be the same? Like where do we cut it off at? Like,
Well,
this
for the
You don't have to worry about that because if the significance of the interaction tells you whether it's meaningful or not.
Okay.
So if you have a significant interaction, then you would look at the slopes to see where it's coming from.
Okay.
But you don't have to really test the slopes per se.
Okay.
Well, you can also do that. There's a little test to test the significance of slope differences, but you don't have to in this case. So once you see there's an interaction, now in this case, this would lead us to a little bit of a dilemma because do we really want to use that covariate or not? We didn't run it without the covariate. Let's do that. Okay, so I'm just going to run the straight ANOVA. And we'll get our standard output for, just a little split file on. Good. Oh, there's the simple effects if you wanted the simple effects, as long as I did them. So, what do I got here? No, I don't think that makes any sense. Never mind. You gotta take the split file off. So this is the ANOVA without the covariate. And we can see we got a way bigger F for, we got a non-significant F for dose, sorry. 2.46.108. So without controlling for the partner's libido, we didn't get a significant difference between the doses. And the means, this mean, look at those two means, they look pretty close to each other. So now you can see you got a little problem here because it looks like for the low dose, the partner's libido made a giant difference. For the high dose, it didn't make much difference. So now you have to kind of decide what you want to do about this. This would probably be one that would be worth controlling the partner, somehow controlling the partner's libido if you possibly could, or splitting it off into some other factors or something like that. It's a silly example, so it's hard to know what to do with that. But just as we said there, this does present a problem for us. Now, do we interpret this? We interpret that ANCOVA as a significant difference. It looks like it is. Once we control for a partner's libido, it's pretty clear from the graph that the high dose has a pretty powerful effect. And the other two really don't have much difference. We don't know yet whether low dose is actually significantly lower than the high dose. We'll do that in a minute. So it's a headache with ANCOVA because if you violate this assumption, you don't exactly know what to do about this. Most people probably would just report this. It's significant enough with the covariate. Probably tells us what we want to know, but there is some messiness to it because of the violation of the assumption.
If you have this violation, so you can't really use the ANCOVA, would it be better to look at it from the treatment by blocks or something, or something?
Possibly, but in this case, no, it wouldn't be treatment by blocks because it's not severity of the libido that's the issue. It would be doing something about the covariate.
Okay.
So I'd say this would be a sign of a poorly designed study. Because I don't see how you could randomly assign people, unless it was in a brothel or something. How are you going to assign the libido of the partner?
Yeah.
That's a random factor that you don't know about. And it's clearly having a big influence on two of the levels, but not so much on the high level, right? So you end up with some weird stuff.
Seems though this affects the means. I'm trying to conceptualize in my head how a different slope is going to affect the mean. Is that flat slope going to increase the mean, or is it going to decrease?
Well, in this case, it increased the mean.
In this case, it increased.
Because it took away the cases some of the cases with low libido are apparently were dragging down the part of the subject's libido, I guess. You don't actually know, but that mean went up with the ANCOVA compared to the regular mean. So it did heighten the effect, which is probably real, but it is a bit of a problem because you don't know how much type 1 error is built into that just because the assumption is violent. And there's a bunch of complicated ways to try to decide how severe the violation. In this case, it was only 0.046. Even though it looks pretty dramatic in the graphs, it's very few data points. It's probably not enough to ruin it most. But maybe you need to run more subjects, or maybe you need to redesign the study or something like that. Okay. So those are the assumptions. The other one we didn't really deal with is the reliability of the covariate, and you can always do that by at least looking at internal consistency or something of it. But honestly, people ignore that reliability assumption pretty regularly. It's not as powerful as the homogeneity of regression. That is pretty important. So you have to kind of come up with sort of a decision tree of what to do in those situations. We'll put together later in the semester. Now, the one final thing is, what if we wanted to compare our placebo to our low dose, including the covariate? Well, let's say without the covariate, how do we do it? How do we do it last semester? If I wanted to just go in and compare low dose to placebo on a one-way ANOVA, how do we do that in SPSS last semester?
We would dummy, or we would compare group 0 compared to group 1.
Yeah, so we'd go into compare means, right? That first non-module compare means, not general linear model. And we would do 1 minus 1, 0. Remember? For the three groups, 1 minus 1, 0 would be the placebo, low dose, high dose. So that would get us the comparison just between placebo and low dose, right? Trouble with that is that there's no place for covariance in that analysis. So you have to figure out a way of using general linear model to do this. And actually, we hit it the first time, we're going to dummy code these guys into some codes that allow us to do that and still use the covariate. So here's the way Andy Fields likes to do that. He created a new file with the dose. Here's the dose code here, but here's a couple of dummy codes. This one is coding -2 for the first group, that's placebo, and then 1 for the other group. So that would be a way of getting a comparison between the combination of these two versus this one, which I don't really think we care about so much, but we might be able to do that one. Here we dummy coded, first group is 0, and everybody else as a 1. Now that's comparing the first group to everybody else as a -1. You can use that. You could use that as any code you want in there. We probably, to do the code we want, we would probably want to do just use our same idea. Why don't we do that? 1, 1, 1, 1, 1, 1, 1, 1. And then we could use a -1 or something if we wanted to for the next ones. Oops. One there. I'm going far enough.
I think you're 1 over.
Okay, so now if I run my analysis, I'm going to do the analysis. So I'll do Vito as a DV, I'm not going to use dose, I'm going to use my dummy code as the fixed factor. I'm going to still put in partner's libido as a CD. Same options. It's important that you put the means over in this one, otherwise you don't get the adjusted means. Okay, so here we get variable 1 is our independent variable. The covariate is highly significant, and we still get a significant difference between 1 and 2. I wouldn't have thought it would be so significant, but I guess it was. And let's see if the means make sense to us. First group was 3.02, the second group was 4.869. So there's quite a bit of difference between those. So now that's with the covariate in there. And then if we tested the assumption here, we're pretty sure we're going to not violate the assumption, right? Those two slopes we know already are pretty similar. So let's just do it. So that would be model, covariate. Now I'll put in model, custom. No significant interaction. Right. We kind of knew that already, but so that means for that comparison we met the assumptions nicely. So you can't. So the trick is you can't do it any other way if you want to get those particulars. You've got to use this trick, some kind of dummy coding trick to do it. You can use a number of different codes for that. All right, does everybody get how to do the model thing? We gave you a little snag to see how to do it. Because you have to do that in the homework. And remember, the most common mistake is people get the second output from the assumption and they interpret that as the meaning of the original one. And it doesn't mean anything except for that interaction. All you care about is the interaction of the second output. When you run it through for the assumption, just look at the interaction. If it's not significant, you're in like Flynn. If it's significant, you got to go back and figure out where it's coming from.
Because if the interaction is not significant, then your assumptions aren't violated.
The assumption of homogeneity of regression.
Okay.
You don't know about linearity or homogeneity of variance, or in this case, I noticed that he had a violation of homogeneity of variance too. Remember from the original output, which means we better, now that one is pretty robust to violation, we'll probably ignore it, but we should probably look and see where it's coming from. Here's the standard deviations in the original data. The high dose had quite a larger standard deviation, so if we square that one, it would be 4 for the variance, and this one would be, I don't know, 3. It must just barely be significant. Doesn't look very different. So remember our F maxes need to be pretty big for us to worry about homogeneity of variance. It's a pretty small sample, so probably have to ignore homogeneity of variance violation in this one and worry more about the other assumption. And then the other reason that static group designs are a problem is that you're almost always going to violate that assumption in the static group design, right? You have 3 separate groups of people. CV, DV is just not likely to be the same correlation for each group of persons, right? So let's say we had, let's see if we can think of another example of this. Let's say we had, let's say we're going to compare deployed troops who were in the Kurdish region of Iraq, which turned out to be very safe and not very many combat experiences, versus in Fallujah. And we wanted to use that somehow as a comparison. Well, those troops are very different troops. I mean, they have very different experiences, they have very different backgrounds probably, there might be more National Guard in one than the other. Now you say, okay, well, I'm going to control for all that with covariates. Well, how many covariates can you have? And how many covariates are you going to put in there? And are they going to really work to do this? And you're always going to have a bit of a mess when you have static group designs. But it may be something that you still need to study, so you just have to do your best to kind of do it. The bottom line is treat it like it's a correlation, not like a random control trial. So you've got an association between being in the north of, let's say, being in the north of Iraq and something happening to them or something, some outcome. You wouldn't want to say there's a significant difference. You could say there's a significant difference, but the interpretation of the significant difference is more like a correlation. It tended to be people in this region had more of something than the other, rather than like you would do from a random control trial. And the same thing is true, I mean, if you, one of our long retired faculty was a research design teacher, and his hobby now is to go through the newspaper and criticize all these epidemiological studies that show you that red meat is good for you, red meat is bad for you. So, I mean, those studies are really iffy because you just can't control for everything. So recently there was a big study showing, especially processed meats, were just death. And the amount of processed meat that you eat is just way shortens your life. Well, if you go through and really carefully control for all the factors in that, because they didn't control for vegetarians, and so the vegetarians had very little processed factor, but they were health nuts, right? The people who eat salami sandwiches every day are not health nuts. They eat a lot of junk food. That turned out to be the big thing that created the mortality differences, not the diet itself at all, but a lot of other factors. So there's always a million of these things you got to be really careful of, even if they try and control for.
Do covariates always have to be on like an interval or ratio scale, or can they be categories?
They can be category, but if they're category, it ends up being like another IV sort of.
Okay.
So you can put them in as a category D, CV if you want to.
So if, some theoretical study, my covariate could be, say I'm doing some like running thing, my covariate could be like type of shoe, like running shoe, boot.
You can't put, you can't put them, because you couldn't code those 1, 2, 3, 4, 5. So you'd have to dummy code those as separate ones. So if it's, natural shoes, if the different kinds of shoes are in different categories, each one would have to be a 1, 0 as a separate CV.
So maybe, I would have to do something like, weight of shoe instead of like category.
Yeah.
Okay.
But let's say you wanted to do marital status, just married, not married. Well, you could put that in as a CV 1, 0. But the easier way to do that is just use that as an independent variable, make sure it doesn't matter.
Okay.
Right? So you kind of get those potential covariates. The other thing we often see is that, final thing quick, if you're doing a study, a treatment outcome study, so many of you will do of some kind, you're going to try to do something to one group and then the control group doesn't get it. And you're doing your group equivalents, and you have a whole bunch of data on all these people. Paula's studying some, right? She's got, so some of these guys are running a study with it. One of our students is looking at 2 different kinds of biofeedback and their effect on brain waves. So, and it's completely randomly assigned, but when you get done, you've got age and BMI and what else we got? We've got a whole demographic sheet of variables. So the first thing she'll do is analyze the group equivalents, right? So you use t-tests for continuous measures and chi-squares for category measures. And you're hoping that your randomization worked and the groups are not different, but out of all of those, something's likely to be different, right? So now the knee-jerk reflex is to use it as a covariate. But you don't have to do that unless it correlates with the pre-post differences, right? Just because there's a difference between the 2 groups, if it doesn't matter in terms of their brainwave measure that we're doing, then you don't have to use it as a covariate, only if it really does influence the outcomes. So you would right away test that to see. And if it does influence it, then you got another headache. Okie doke. That's all we're going to do in COVA. We'll review it again later.
I know a lot of people are having trouble, I don't know if this class is, but I've talked to the other class about the homework that's due tomorrow. Chapter 16, if people couldn't get it up or something, they're having
Is that the one? That's not the one you were asking about. What's the problem with that one? That's an Amos one?
Yeah, they weren't able to get the information out.
You can't get it to work on the computer, is that what you're saying? Guys, you don't know? Anybody get it to work? Somebody tried?
I think,
What happens? You just can't get Amos to
They
work?
can't get, like, the data file will come up.
Okay, so you have to load that data file in SPSS first. And you can get that data file in SPSS?
Yeah.
Okay, then when you go to Amos, what happens?
you have to load the file.
The file will load. I know the other class literally just canceled that part of it because it wasn't working. Dollenberg just canceled it.
Just cancel that homework. So that, what were we supposed to do with an SEM? Is that an SEM?
Yeah, it's just
So
basically straight up Amos.
I wonder if it's just a mistake in getting into Amos. So it actually loads in the SPS.
It doesn't load at all.
It doesn't load at all. Oh, okay. Well, if you can't do it, you
But
can't do
someone
it.
might have been able to figure it out.
Well, it doesn't sound like anybody has so far. So is there a substitute we can use for that one? Last year, maybe?
No, they use the same problems they did last year.
Oh, that's the same.
data set.
It's a double one. But that's the only one for us.
Yeah, well, forget it then. If you can't do it, you can't do it. We'll try to work on, we'll have a little bit of time left. We'll do another SEM sometime later in the semester. Yeah, well, I guess if you can't do it, I mean, what are you going to do? I didn't try to load that data, but if you can't get that data to load in the first place, then you can't do it. That was due tomorrow.
I know, I mean, I usually have trouble getting stuff up with the entire other class, but all their stuff is due today, and none of them could do it either.
Okay.
So that's,
Okay, well, good. Thanks for pointing it out. I didn't know that. So we did one with the confirmatory already, right? You guys were able to do that. Yeah. So we'll spend a little time later on SEM. We're a little bit ahead of the class anyway, so we'll go back through and do some SEM. So we wanted to re-go over over-identified, under-identified, reproduce. We'll do a little bit of that later in the semester. I think we have some time we can do that. So you're off the hook for this homework.
So just the chapter 12 assignment is due tomorrow?
Chapter 12 is a different one, right?
Right.
Yeah, that's good. Yeah. But then the one for next week would be the 16, or was that?
No, there were two of them.
Oh, there are two of them, yeah, so just do chapter 12. Right, that's plenty to do anyway, that's right. But just make sure that you practiced enough with the confirmatory so you know how to do all the mechanics of it, right? It takes forever to learn how to do that. But I mean, on the other hand, you guys did great on the output. From the Amos output, that was by far better than the factor analysis output, which I thought was going to be the opposite, so it shows what I know. Okay, well, thanks for pointing that out. Everybody get that? So just chapter 12, not chapter 16. We'll try and figure out, we'll try to get another data set for you for 16. What was that data set about in 16? Anyone remember?
I don't know. I don't remember.
Yeah, I wonder what happened to that file.
I don't know if they just, something happened online.
It must have been, they just corrupted the file or something, nobody could do it. But I need to find another file, so I'll do that later in the semester. Even if we just do it, maybe we'll just do it all together in class instead of the homework. I think that's a good way to do it, so everybody can. Okay.